Alright, so we're told to find the area of the region bounded by the graphs of the equations. Y equals 7 plus cube root x equals 0, equals 8, and y equals 0. So what are we really evaluating? We're evaluating the area under this curve. We're evaluating the area under this curve as x goes from 0, which is right here, all the way to 8, which is up here. And y goes from 0, which is here, y goes from 0, which is there, all the way up to the curve of the graph. And what's the curve of the graph? The curve of the graph is 7 plus cube root x. 7 plus cube root x. So we're evaluating everything within this region. Everything within this region. Everything within that region. So how do we do this? Well, we use the fundamental theorem of calculus, which says as x goes from a to b, as x goes from a to b, as f of x dx goes from a to b, this equals f of x, big F, because this has been integrated, to big F of x, evaluated a to b, which fundamental theorem of calculus means f of b minus f of a. And if you don't understand that, that's fine, because we're going to use the numerical values here in a second that we're given in the equation. So what's our a and what's our b? We'll start there. So our a, area, so big A, area, don't get that confused with little a. Our area is equal to the integral a, well, x is going from 0 to 8. So a is 0 and b is 8. X is going from 0 to 8. What's our f of x? Well, that's just the top portion of the graph here. The top portion of the graph here, all along here. You get the point. That was bad drawing. But all along here, and that's just equal to 7 plus cube root x. And we still have our dx here. Now, when I evaluate integrals, and what I recommend is don't leave that cube root x like that. Don't leave that cube root x looking like that. So our area, we're just going to simplify it a little bit further. X goes from 0 to 8. 7 plus cube root x can also be written as x to the 1/3. That's the same as that. If it was the square root, it'd be x to the 1/2 dx. Now from here, we can go ahead and evaluate the integral. Well, what's a constant go to? Constant just gets multiplied by the variable, whatever variable's in question. So we now have the area equals 7x plus x to the 1/3. What happens to x to the 1/3? Well, x to the 1/3 goes to x to the 1/3 plus 1 over 1/3 plus 1, which is saying the same as x to the 1/3 plus 3/3 over 1/3 plus 3/3. So we get 7x plus x to the 4/3 over 4/3. Which we can write this, and since we evaluate the integral, now we put our brackets there. We still have to evaluate the function as it goes from 0 to 8. We still have to use the fundamental theorem of calculus there. But before we do that, let's change around. A equals 7x plus. Let's go ahead and simplify this part further. Now we have x to the 4/3. So over a fraction, over 4/3 is the same as saying over 4 times 3. Over 4 times 3. And this is evaluated from 0 to 8. Now we just plug in the values, kind of like where we were here at this stage. We evaluated the integral, and now we had to evaluate it as it ran from a to b, which goes f of b minus f of a. So f of b minus f of a, f of b minus f of a, our area equals 7, because we're going to evaluate it at 8 first. 7 times 8 plus 3 times 8 to the 4/3 over 4. Minus f of b minus f of a. Well, what's f of a? F of a is f of 0. So 7 times 0 is 0, 3 times 0 is 0, so it's minus 0 plus 0. So it makes this really easy. We don't have to worry about anything in our second term here. So now we just add all this up. We get our area equals 7 times 8 is 56 plus, when solving this junk over here, I first look what's the cube root of 8, and you could do this. Doesn't matter the order you do this, you run this fraction at. So what's the cube root of 8? Well, that's 2, because 2 times 2 is 4 times 2 is 8. What's the cube root of 8 to the 4th power? So what's 2 to the 4th power? 2 to the 4th power is 2 times 2 is 4 times 2 is 8 times 2 is 16. So we get 3 times 16 over 4 equals 56 plus 16 was 4 was 3, 12 equals, oh, I ran out of room. Alright, equals 68. Our area equals 68. And now we don't have to really worry about any left approximations or right approximations. It's that easy. Our area equals 68.